On every bounce, it bounces 4/5 of the previous height. If allowed to bounce forever, what is the total back and forth distance the ball travels over? Notice that's total, so it's up and down. So let's draw a picture to help ourselves see what's going on here. So we start off, we've got this ball, we drop the ball, and it falls 3 meters. Then it bounces, right? It's a super ball, so it bounces up, and it will go up by how much? It will go up by 3 times 4/5. Right? Because it goes up to 4/5 of its previous height on every bounce. Now it's going to fall down. Well, what height did it just fall down from? It's going to fall down from the same thing, 3 times 4/5. Then it's going to bounce up again. It's going to bounce up by how much? Well, it's going to bounce up to 3 times 4/5 times 4/5, because it's 4/5 of the previous height it came from. 3 times 4/5 times 4/5, well, we could just write that as 3 times 4/5 squared. Then it's going to fall down once again from that same height, so 3 times 4/5 squared. And then it's going to just continue on in this matter of going a little bit less each time. So 3 times 4/5 cubed, and then down again, 3 times 4/5 cubed, and just continuing on in this matter forever. So we want to figure out the total back and forth distance the ball travels over. So notice what we've got here is we've got ups and we've got downs. So I'm going to go with calculating the ups first. How much is from this up plus this up plus this up, going on forever and ever and ever and ever. So notice what that means we're dealing with is we're dealing with an infinite sum, because we're saying if it were to bounce, continue bouncing forever, what would be the amount of distance it would travel over? So that is equal to the first value times 1 over 1 minus the rate. That was what we figured out the infinite sum comes out to be. So first value times 1 over 1 minus the rate. All right, so in this case, for our up jumps, our up bounces, the up bounces, all the ups, so all ups is going to wind up being, our first value is A1, so our first value is this one right here, 3 times 4/5. We might be tempted to think it's 3 meters, but remember, this is all the ups. We're looking at the ups first, and we'll see why at the end, why I chose to look at the ups first. So all ups, that's going to be 3 times 4/5 is our first value that we wind up having occur. And then that's going to be times 1 over 1 minus, what's the rate? 4/5, because it's 4/5 on every bounce. It goes up to 4/5 of its previous height. So the rate for the next one will be 4/5 of that, then 4/5 of that, then 4/5 of that. Notice there was one other requirement on being able to use this. The absolute value of our rate must be less than 1, but since it's 4/5, that winds up checking out. Okay, keep going with this. So that's 3 times 4/5. Let's write it as 12/5. 12/5 over, 12/5 times 1 over 1 minus 4/5 is 1/5. Well, 1 divided by 1/5 is 12 over 5 times 1 over 1/5 is 5. So we've got 5 times 1/5 on the bottom, cancels out. So we've got 12 meters total of bouncing for our up values. So 12 meters total for our up values. Okay, but that's only part of it. Now we also have to figure out what are all of the down values, right? What's the down value here, the down value here, the down value here, going out this way infinitely? Well, we've also got this part right here. But notice, all of these green things, they wind up having a matching up value, right? They each match up. The purple and the green, the purple ups and the green downs all match up. The only guy who's sort of out of the normal case of matching up is that red first drop down. So what that means is that we can match all of our downs has a matching 12 meters because it matches all of the ups, but then we just have to add on the initial 3-meter drop at the beginning. So how many downs do we have in total? Well, that 3-meter drop plus the match value, because it matches to the 12-meter value for all the ups. So 12 meters plus 3, we get 15 meters. So the total number is going to be equal to the 12 from our ups plus the 15 from our downs. 12 plus 15 means 27 meters in total. Great. There we are. Finished that one. All right. So now we've got a pretty good understanding of how sequences work. We've worked through geometric sequences, arithmetic sequences. We understand how series work. We've got a pretty good idea of how sequences work. So great. All right. We'll see you at Educator.com later. Bye.